Are you struggling to crack the coding interview or aiming to master the core pillars of computer science? Data structures and algorithms are the foundation of every high-performing application. In this video, we will cover DSA fundamentals, practice questions and answers, data structures and algorithms. Interview prep. Master your data structures and algorithms fundamentals with this comprehensive practice guide. In this video, we dive deep into 30 essential DSA fundamentals practice questions, covering everything from Big O notation to complex tree traversals and dynamic programming concepts. Make sure to grab a pen and paper to track your score as we go through these exam-style questions. What is the time complexity of accessing an element in an array by its index? Option A, O, 1. Option B, O, n. Option C, O, log n. Option D, O, n squared. The correct answer is A. Arrays are stored in contiguous memory locations. Because the size of each element is constant, the memory address of any element can be calculated directly using the formula base address plus index asterisk size of element. Since this calculation takes the same amount of time regardless of the array's size, the time complexity is constant, or O, 1. In a singly linked list, what is the time complexity to delete a node given only a pointer to that node, not the head? Option A, O, 1. Option B, O, n. Option C, O, log n. Option D, not possible without head. The correct answer is A. If you have a pointer to the node to be deleted, you can copy the data from the next node into the current node and then delete the next node by adjusting the next pointer. This trick takes constant time. However, note that this doesn't work for the last node in the list generally. In a theoretical sense, for a middle node, it is O, 1. Which data structure follows the last in first out, LIFO, principle? Option A, queue. Option B, stack. Option C, linked list. Option D, max heap. The correct answer is B. A stack is a linear data structure that follows the LIFO, last in first out, principle. This means the last element added to the stack will be the first one to be removed. Common operations include push, add, and pop, remove. Examples include undo mechanisms in editors and function call stacks in recursion. What is the worst-case time complexity of searching for an element in a binary search tree, BST? Option A, O, log n. Option B, O, n log n. Option C, O, n. Option D, O, 1. The correct answer is C. While a balanced BST offers O, log n, search time, the worst-case scenario occurs when the tree becomes skewed, essentially looking like a linked list. In a skewed tree, you may have to traverse all n nodes to find the target or determine it's not there, resulting in O, n, complexity. Which of the following sorting algorithms is stable and has a worst-case time complexity of O, n log n? Option A, quicksort. Option B, merge sort. Option C, selection sort. Option D, bubble sort. The correct answer is B. Merge sort is a divide and conquer algorithm that guarantees O, n log n, time complexity in all cases. Best, average, and worst. It is also stable, meaning it preserves the relative order of equal elements. Quicksort is often faster in practice but has a worst case of O(n squared) and is not inherently stable. Which tree traversal visits the nodes in the order left, root, right? Option A, pre-order. Option B, post-order. Option C, in order. Option D, level order. The correct answer is C. In order traversal visits the left subtree first, then the root node, and finally the right subtree. In a binary search tree, BST, an in-order traversal results in the elements being visited in non-decreasing sorted order. Which data structure is typically used to implement breadth-first search, BFS, on a graph? Option A, stack. Option B, queue. Option C, priority queue. Option D, hash map. The correct answer is B. BFS explores the neighbor nodes first before moving to the next level neighbors. A queue, FIFO, is used to keep track of the nodes discovered but not yet visited. When a node is visited, all its unvisited neighbors are added to the back of the queue. What is a collision in a hash table? Option A, when two different keys produce the same hash value. Option B, when the hash table runs out of memory. Option C, when a key is deleted from the table. Option D, when the hash function returns a negative value. The correct answer is A. A collision occurs when two distinct keys are mapped to the same index by the hash function. Since a single index can usually hold only one piece of data in a simple array, strategies like chaining, using linked lists, or open addressing, finding another empty slot, are used to resolve these conflicts. In a circular queue implemented using an array of size n, how is the next position of the rear pointer calculated? Option A, rear plus 1. Option B, rear plus 1%n. Option C, rear %n plus 1. Option D, rear plus 1%n. The correct answer is B. In a circular queue, when the pointer reaches the end of the array, it needs to wrap around to the beginning. Index 0. The modulo operator, %, is used for this. If rear is at index n1, n1 plus 1, %n equals 0, correctly pointing to the start of the array. What is the prerequisite for performing a binary search on a list? Option A, the list must be unsorted. Option B, the list must be sorted. Option C, the list must be implemented as a linked list. Option D, the list must contain only integers. The correct answer is B. Binary search works on the principle of divide and conquer by comparing the target value to the middle element. This logic only works if the list is sorted. If the target is smaller than the middle, you search the left half. If larger, the right half. Without sorting, this elimination is impossible. What is the space complexity of a recursive function that calculates the north Fibonacci number? Without memoization? Option A, O, 1. Option B, O, n. Option C, O, 2 caret n. Option D, O, log n. The correct answer is B. The space complexity of a recursive function is determined by the maximum depth of the recursion stack. To calculate fib n, the call stack reaches a depth of n before it starts returning. Even though the time complexity is exponential O, 2 caret n, the space complexity, stack depth, is linear O, n. In a max heap implemented as an array, if a node is at index I, what is the index of its left child? Option A, 2i. Option B, 2i plus 1. Option C, 2i plus 2. Option D, I, 2. The correct answer is B. For a zero-indexed array representation of a binary heap, the left child of a node at index I is always at 2i plus 1, and the right child is at 2i plus 2. The parent of a node at index I can be found at I1, 2. Which algorithm is used to find the shortest path from a source node to all other nodes in a weighted graph with no negative edge weights? Option A, Prim's algorithm. Option B, Kruskal's algorithm. Option C, Dijkstra's algorithm. Option D, Bellman-Ford algorithm. The correct answer is C. Dijkstra's algorithm is a greedy algorithm used for finding the shortest paths between nodes in a graph. It works specifically for graphs with non-negative weights. If the graph has negative weights, the Bellman-Ford algorithm must be used instead. Which sorting algorithm repeatedly picks the smallest element from the unsorted part and puts it at the beginning? Option A, insertion sort. Option B, selection sort. Option C, bubble sort. Option D, quick sort. The correct answer is B. Selection sort works by maintaining two subarrays, one already sorted and the other unsorted. In every iteration, the minimum element from the unsorted subarray is picked and moved to the sorted subarray. It has a time complexity of O, n squared, in all cases. What is the main advantage of a doubly linked list over a singly linked list? Option A, uses less memory. Option B, faster access to elements by index. Option C, can be traversed in both directions. Option D, easier to implement. The correct answer is C. A doubly linked list contains an extra pointer, previous, in each node pointing to the previous node. This allows for bidirectional traversal, forward and backward. However, this comes at the cost of extra memory for the additional pointer. Which data structure is most efficient for implementing a priority queue, where elements are retrieved based on importance? Option A, sorted array. Option B, unsorted linked list. Option C, heap. Option D, stack. The correct answer is C. A binary heap, min heap or max heap, is the most efficient structure for a priority queue. It allows for O log n insertion and O log n removal of the lowest priority element, while keeping the structure balanced. A sorted array would take O n for insertion. What is the maximum number of nodes in a binary tree of height h? Assume root is at height O. Option A, 2 caret h. Option B, 2 caret h plus 1, 1. Option C, 2 caret h1. Option D, 2h. The correct answer is B. A full binary tree at height 0 has one node, 2 caret 1 to 1. At height 1, It has 3 nodes. 2 to 1. The formula for the maximum number of nodes in a binary tree of height h is 2 h plus 1. 1. If an algorithm's time complexity is O, n log n, and the input size doubles, by approximately what factor does the running time increase? Option A, 2. Option B, 4. Option C, slightly more than 2. Option D, log n. The correct answer is C. If we replace n with 2n, the new time is 2n asterisk log 2n, which is 2n log n plus log 2 equals 2n log n plus 2n. This is slightly more than double the original time. 2 asterisk n log n. This makes O, n log n, very efficient compared to O, n squared. In hash table open addressing, what is linear probing? Option A, using a second hash function. Option B, searching for the next available slot sequentially. Option C, creating a linked list at the hash index. Option D, rehashing the entire table. The correct answer is B. Linear probing is a collision resolution technique where, if a collision occurs at index I, the algorithm checks index I plus 1, I plus 2, I plus 3, and so on, until an empty slot is found. This can lead to primary clustering, where blocks of occupied slots build up. What is the time complexity of depth-first search? DFS. On a graph represented by an adjacency list, where V equals vertices, E equals edges. Option A, O, V. Option B, O, E. Option C, O, V plus E. Option D, O, V asterisk E. The correct answer is C. In an adjacency list, DFS visits every vertex once, V, and explores every edge once, E, for directed graphs, or twice for undirected. Thus, the total time complexity is O, V plus E. If an adjacency matrix were used, it would be O, V squared. Which of these is a divide and conquer algorithm? Option A, bubble sort. Option B, selection sort. Option C, quick sort. Option D, insertion sort. The correct answer is C. Quick sort is a divide and conquer algorithm. It picks an element as a pivot and partitions the given array around the picked pivot. It then recursively sorts the subarrays. Merge sort is another famous example of this paradigm. Which data structure is best suited for implementing an undo feature in a text editor? Option A, queue. Option B, stack. Option C, hash map. Option D, tree. The correct answer is B. The undo feature requires accessing the most recent action first. This perfectly matches the LIFO last in first out property of a stack. Every time an action is performed, it is pushed onto the stack. When undo is pressed, the top action is popped and reversed. In a binary search tree, which node is the successor of a node X with a right child? Option A, the parent of X. Option B, the rightmost node in the left subtree of X. Option C, the leftmost node in the right subtree of X. Option D, the root of the tree. The correct answer is C. The in-order successor of a node is the node with the smallest key greater than the key of the input node. If a node has a right subtree, the successor is the minimum element in that right subtree, which is found by going to the right child and then following the left pointers as far as possible. What is the time complexity of the following code snippet? For int I equals 1, I less than n, I equals I2, Option A, O, n. Option B, O, n squared. Option C, O, log n. Option D, O, sqrt, n. The correct answer is C. The loop variable, I, doubles in each iteration. 1, 2, 4, 8, 16. This means the number of iterations, k, is the power to which 2 must be raised to reach n. 2 caret k equals n. Solving for k gives k equals log 2 n. Hence the complexity is O log n. What is a cycle in a graph? Option A. A path that starts and ends at the same vertex. Option B. A graph where every node is connected to every other node. Option C. A node with no incoming edges. Option D. An edge that connects a node to itself. The correct answer is A. A cycle in a graph is a non-empty path in which the only repeated vertices are the first and last vertices. In simple terms, if you can start at a node and follow a path of edges to get back to the same node without reusing an edge, the graph contains a cycle. Which of the following growth rates is the slowest? Option A, O, n. Option B, O, n log n. Option C, O, log n. Option D, O, 2 caret n. The correct answer is C. Logarithmic growth O, log n, is much slower, and therefore better for large data, than linear O, n, log linear O, n log n, or exponential O, 2 caret n. For example, if n equals 1 million, log n is roughly 20, while n is 1 million. What happens if you try to pop from an empty stack? Option A, overflow. Option B, underflow. Option C, garbage collection. Option D, recursion. The correct answer is B. Underflow is a condition that occurs when you attempt to remove or pop an item from a data structure that is already empty. Conversely, overflow happens when you try to push an item into a data structure, like an array-based stack, that has reached its maximum capacity. What is the time complexity to heapify an array of size n to build a heap? Option A, O, 1. Option B, O, log n. Option C, O, n. Option D, O, n log n. The correct answer is C. Although inserting n elements into a heap one by one takes O, n log n, the build heap operation, heapify, can be performed in O, n time by starting from the last non-leaf nodes and working up to the root. This is a common point of confusion in DSA exams. In an AVL tree, what is the maximum allowed difference between the heights of left and right subtrees for any node? Option A, 0. Option B, 1. Option C, 2. Option D, log n. The correct answer is B. An AVL tree is a self-balancing binary search tree. The balance factor for any node is calculated as height of left subtree, height of right subtree. In an AVL tree, this factor must be -1, 0, or 1. If it deviates, rotations are performed to rebalance the tree. Which sorting algorithm is often used in practice for small arrays or as part of a hybrid algorithm? Like timsort. Option A, quicksort. Option B, merge sort. Option C, insertion sort. Option D, heap sort. The correct answer is C. Insertion sort is very efficient for small datasets and nearly sorted arrays. Because of its low overhead, modern hybrid sorting algorithms like timsort, used in Python and Java, use insertion sort when the subarrays become small enough during the merge process. That wraps up our 30 practice questions on DSA fundamentals. How many did you get right? Let us know your score in the comments section below. If you found this helpful, hit the like button and subscribe for more deep dives into computer science concepts. For the full practice exam and certification prep, check the link in the description below.